Like a mom.
Polynomial operations. So before we do some operations with polynomials, tell me this. What is a polynomial? Polynomial. Multiple. Poly means multiple. It's got multiple terms. So I'm going to say
No means number.
one or more terms. When I say terms, what am I talking about?
Ways of doing it.
Numbers.
Numbers that fit the answer.
Numbers and variables, I'm talking about some expressions, things like 2x, 5x to the third, 6x squared. Those are all terms, okay? So it's got one or more terms to be a polynomial. It also has to have positive
Answers.
whole number exponents. Okay? All the exponents that are hooked to the variable must be positive whole numbers, and that's what makes it a polynomial. Okay. About how we can multiply two terms together versus how we add two terms together.
Wait, go back for a second. I got one word left.
I thought it was always multiplication and division together.
Alright, so whenever I'm talking about multiplying versus add, I'm looking right now just at individual terms before we get to the whole polynomial. So if I asked you to multiply 2x to the third times 4x to the second, what do you do?
Hey, you multiply the base numbers and you add the exponents.
Alright, so you multiply, because this is really 2 times x to the third. This is the same thing we were doing with our properties of exponents.
Yep.
Okay, so we multiply the coefficients, not the base, because remember we leave the base alone. The base on these is x.
But when you separate them, they're both bases.
And we add
The exponents.
the exponents.
So it's 8 to x5.
Exactly. And I want you to have this in your notes in the multiplication versus adding, because whenever you start doing both operations, it starts getting jumbled around in your head. It always does.
Yeah, I gotta ask you
But
a
it's going to be a
serious
whole
question.
polynomials, not just individual terms.
Do you believe it goes?
Tell me, before you add terms, you can't add any two terms together. They have to be special. What has to be special about them?
They have to be the same base.
They have to be, to add, they have to be same base and same, what?
Exponent.
Exponent.
Yeah, I said that. What?
What is that called if they have the same base and the same exponent? Yes, yes. That's called like terms. You can only add or subtract like terms. Okay? Same base, same exponent. So when you do that, what do you combine?
Your exponents.
Everything.
Like if you add these two
You
together.
just
add
added
numbers.
what's in front of x.
That's 9x4.
You
No,
all,
9x
so you're
squared.
only combining the what?
It's 9x
Coefficients.
squared.
Coefficients. That's what I wanted you to get to. So you combine the coefficients, but you leave the base and the exponent, right? So several of you are yelling, so that's
9x2 and x4.
9x squared.
Welcome.
Oh, so we just leave it the same.
You leave it, right, okay? So I really want you to have a good handle on when we multiply what it is we're doing and when we're adding what we're doing.
What about subtracting? Dividing.
Why don't you write it? All right. Y'all got that? Okay, let me pause it a second. Let's extend it to polynomials. So today we're going to do addition, subtraction, and multiplication. We'll do division at a later time. So addition. I I'm not sure yet. I have to look.
Can I work this one out?
Let him work it out, please.
Let me give the first example. Let's say I had 5x to the 5th.
Wait, give me a second.
What?
Alright, you're good to go.
6x to the 4th minus 3x squared plus
You say
2
plus 6x to the 4th?
Have
plus,
you lost your mind?
just wait,
Just wait.
4x to the 4th
Oh, I don't.
minus 2x cubed minus
Well, Miss McGee.
7x squared plus 8x.
You can do that if you want to.
Now, this looks tough, right? It usually lets you go,
You should put that under it.
No, that's one of those where you're just like,
Unfortunately, you can't do this one on a calculator like that. Yes, Kevin?
I can tell you one thing.
You could if you had a program.
I know for a
Just
fact,
move down 5x.
Can't you just add like terms?
I know for a
Yes.
fact,
No.
you can't add like terms because x is not the same as the exponents.
Wait. The only thing you're gonna do with this is addition commutative like multiplication. In other words, can you add in any
Yeah.
order?
Yeah, you
Sure,
can.
right? So all you got to do is look for the ones that are like terms. So I always look for the biggest exponent first. What's the biggest exponent you see?
4.
Look at you.
5.
5.
Oh, you
I
can't
see an
add
exponent of
something.
5,
Just move
right?
that down.
There's no
Just
other
move that down.
There's no other exponent of 5, so there's nothing else I can do. So I have 5x to the 5th.
You have 4.
Okay? So let's work our way down from there. Do you have any exponents of 4?
Oh, 6 plus 4, you just keep the code, the exponent, right?
Yes.
I did right.
Remember, when we add terms,
Right.
and watch, we're going to have to watch the signs.
Alright,
But
no.
when we add terms, we add the coefficient in front, we leave the variable in the exponent. So this becomes
10x to the 4th.
Hey, you can bring that 2 down too.
keep them in order
You
though.
got 7x
We
2.
like to keep things
Oh,
in
keep
order.
negative 2x 3.
-2.
Bring negative 2x
Okay,
3 down.
and everybody, here's what I'm saying, right? Keep them in order from the biggest down to the smallest, because that's pretty math.
3x to 7.
Powers of 3, exponents of 3.
Negative 2x to the 3rd.
I only have 1,
So just bring it down.
so bring it down.
You couldn't put just, you couldn't work left to right and go -3x to.
You really want to keep your exponents in descending order. It's standard form of a polynomial.
So you got
Yes,
3x,
The
negative
next one is
3x.
negative 10x to the second
Yes.
And then it's 8x, and then it's minus 2.
My x squareds, they're both negative, so be careful.
Positive or
Add 'em
negative
together,
nine.
negative
Add them together and get negative 10x squared. No. Yes.
And then are we?
And this is how I work through it whenever I work through it, and I mark off as I use them so I know.
Add 8x because you know 2 and 8x, 2 doesn't have an
There's just one x, and it's 8x. That's here.
And there's just 1, 2.
And there's just the 1, 2.
That's the end of the problem.
So literally all I'm doing is looking for like terms and combining them. Does that make sense?
Yes. Don't solve it at all.
Is that it? Leave it like that.
You never solve unless you see an equal sign in the problem and it says solve.
This whole entire.
In that case,
chapter
that'll be more
is
complicated.
About combining like stuff that's alike.
Wait, I have another question. What if it was like, say 5x and 10 is 4? There's an equal sign, and after the equal sign is 2x.
We're not getting into solving right now.
So
We will, but
Okay, so that we will.
difficult.
if they have the same power, you just like combine them.
Yes.
Okay, so it doesn't matter about the base.
You mean the coefficient?
Yeah.
Yeah, that doesn't matter. You can combine any coefficients. You just have to make sure the variable and the exponent are the same.
Can we try one?
Yes.
I'm pretty sure everyone knew this.
Let's see. DeAndre, wake up.
I am up.
No, you're not.
I was
Stand up. That's what Miss Class
I was
is.
just praying. Praying
Quit.
that I-
If you close your eyes just for a second, you're gonna feel you sleep.
Aren't you guys technically out of the
No,
state?
we're still going to playoffs.
What?
Y'all gonna lose.
All right.
I thought it was top 8.
You raised this bandwidth.
Not
You know
everybody
more
gets
than y'all
perfect,
do
because
for
we're gonna
the
say
set.
Columbia home.
Y'all.
All right, try this. Hit record. I see a 2 and a 6, which gives me 8. Powers of 3, -3 and -2 would give me
Negative
-5.
To the third.
I only see one power of 2,
Only one X.
only one x.
0.
And -10.
-5 and -5 is -10.
Dang it.
Did y'all get it right?
Yes.
Let me see your hand if you got it right.
Can I use the restroom on that now?
Yes.
We
All right, so subtraction. The nice thing about subtraction, and we're getting the easy ones out of the way first, because addition and subtraction is easy. Subtraction, if you can do addition, you can do subtraction, okay? Because all subtraction is,
I don't think it's top row.
3x cubed minus 6x squared plus 5x minus 3. When I'm doing subtraction, here's the only thing you have to do different from addition.
you have to do the math.
You have to subtract.
If you
Do we
do
do
same, yes.
Same change.
Here's where it's different though. I'm gonna change this, but understand whenever I change this sign, I'm
You change every
subtracting.
sign, every behind it.
Exactly. I'm subtracting everything in this parentheses.
No, you're not. You adding
So
those
just
two.
keep
and
that change.
You know what? You can go
Boop. Boop. Go sit down.
make this positive.
So I like to say that these are same change everything kind of deal, okay? So here I change the middle sign and then I change.
How you know?
Wait. Okay. Why would you do all that?
Okay?
Because she wants.
If you can see it, if you can see it in your head, you don't have to do that. Guys, what you have to think though is this is going to be 2x cubed minus 3x cubed. And it's going to be 5x squared minus negative 6x squared. So if you change the signs, sometimes it's a little easier to see, so then it's an addition problem, but you don't have to.
Wait, hold on, guys.
Yeah, boy.
All right. Keep the first parentheses same.
Wait. What do you want, bro?
Now combine your like terms.
Can I do it? Can I do it on the board?
Let him do it.
You said I could do it right. Two.
Can I do it on the word?
X3?
No.
2 and -x3.
That's because you think I'm.
5 and positive 6x.
What is 2x cubed and negative 3x?
Negative
Negative x
one.
cubed.
1.
Oh, you can't put the one. Please put the one.
Please put negative.
Please stop talking.
All right.
11x squared.
I've got 5
It's 11x squared.
and 6, which is 11.
X squared, and then you got, what's that, -3x plus 4.
Negative 8x, nope, and negative 5x.
-3.
You gotta
I said
change that
negative- I
5.
said -3.
It's not.
Oh,
Negative
you got a
13.
negative up there? Can't say it. Make that a little more clear.
And now for my constants, I have 3 and 1, which is quadruple. Does that make sense to everybody?
Yeah.
Maybe.
Yes.
No complaints.
All right. Let's do multiplication because it's the hardest.
We should save that for another week.
No.
Or another week.
All right. Lace up your boots.
I'm not even going to.
This is what I'm fixing to show you. If whenever we were multiplying the two factored pieces out, whenever we did the foiling, and I told you I didn't really like foiling, I like distributing. If you learned it as distributing, you won't have a problem with this because it's the same thing.
Yay.
All right,
She learned all this stuff in ninth grade.
multiply. I'm going to start with a kind of a smaller one.
Side friend. So he's a 10th grade.
Where's this in grade? I'm in third grade.
Yeah, I can tell.
Okay. I want you to take a look. Shh, guys, focus. I know we've been at this a while, but I'm almost done, I promise.
What class
Look
is
at
it?
these two
You got class work?
that I need to multiply. Okay? Here's the key. Now, we talked about how we multiply terms. Okay, we multiply the coefficients, we add the exponents. For these,
You gotta.
every term
gets multiplied.
in the first distributes
In the second, he said it.
to every term
No, I thought you were.
in the second.
Yeah.
Take the first, I always circle the first term. Okay? And I start distributing that term through to the second polynomial. Alright? So 2x to the third times x squared is what?
6.
Exponent.
2x,
6.
no, to the fifth.
Oh, we're
Remember, look back, remember we did that in the very beginning? Add versus multiply? When we multiply the coefficients, we add the exponent.
Which example is this? This is our third or second, or
First.
First under
So
multiply.
what, now we go 2x? To
Okay.
2x to the fifth?
So now we take it here.
One more.
So 2 times 2,
It's gonna be, what is that?
4.
4x to the sixth?
No, guys.
It's 4x to the third.
This is F1.
4x to the fourth.
4x to the 4.
Wait, what?
Listen guys, listen. Multiply coefficients, add exponents. Multiply coefficients, add exponents. Look at the next one.
So how did it get to 4
Negative
from
2 to the fourth.
Oh, okay, I thought you were
Negative
doing
2x
it
to
to
the
2x to the fifth.
Negative 2x to
Never
the
mind.
third.
It's just times 1.
Oh, hold on. You're distributing through all of them?
Yeah.
So this is gonna be really, really long.
Yes.
Oh, come on.
That's why you put it so small.
Yes.
I don't like
Okay.
It makes sense.
All right. I have now distributed the first term through. But that's not enough. I'm done with this one, now it's this one's turn. Okay, so let's start. What is 4x times x squared? 4x to the third.
You're done?
What is 4x times 2x?
8x in a second.
8x second. Now we're getting it. What is 4x
Negative
times
4x.
negative 4x? Does that part make sense to everybody? Okay? Done.
Then we do 5.
5x.
But it's negative 5, so be
Negative
careful.
5x to the second.
Negative 5x to the second.
Negative 10x to the first, and then positive 5.
I do some shade thrown in here while this is out.
Plus 5. Keep it on math.
This is like,
Okay.
Yeah.
I'm still not quite
You
done.
have to combine them.
Because after I do this, I must combine like okay? So take a look at my new polynomial, my very colorful new polynomial.
I like it.
Me too. Let's start with the biggest exponent and work our way down. We've got a power of
2x to
5.
the fifth and 4x to the fourth.
Okay, wait. Speed racer. 2x to the 5th. Powers of 4, I only have one of those also. Now powers of 3.
Got it.
2 of those. Oh my
2 of
gosh.
those. Negative 2.
Third.
That's right.
Hold on.
Okay.
3x.
Whoa, what?
Negative 2.
Hold on.
Alright, now you got 3x squared.
Hold on, Tyler's thinking about it. Wait a second.
Thinking back, okay. So 4x. Y is oh no, not that. I'm just thinking.
True enough.
He's not talking about the.
Where did we get 3?
3.
Yeah, where did we get 3? Where did we add?
Look, okay, so it was the last one of the yellow, so 2x cubed minus times negative 1. And then it was the first one of the blue, so 4x times x squared.
Okay. I'm going back here.
Yes, Phoenix.
So we have these on the homework. You need to give us like 10 of them.
Hold on.
Oh,
Phoenix.
can I do the rest?
Is that 2x
to the fifth plus 4x to the fourth plus 42x to the third.
What do you see 42?
Is this the full answer is what I'm gonna ask?
4x to the
Is this
third.
the full
I'm talking
answer?
about the
2x to the fifth plus 4x
Oh, 4x to the fourth plus 2x to the
plus
third.
3x
I
to the
didn't see it
second
plus-
minus 14x plus
Yeah.
5.
Yeah. Is everybody with me at this point?
I think.
Now look at your powers of 2.
No, there's only one, so it's.
There's two.
No, there's 2.
It's 3x squared.
Yeah, I messed this thing up.
You have to be careful because here's what you're going to do. And I'm telling you because I've taught this so many times for so long.
You got 2 from 4x times 2x.
If your properties are what you do when you multiply versus when you add, I'm telling you, you're going to start adding exponents here. That's why I really want you to keep it straight. What am I doing? I'm adding. When I add, I leave the exponent alone. What am I doing? I'm multiplying. If I'm multiplying, I add the exponents. Yes, Tyler?
So you got 2 from 4x times 2x. So 8x squared.
The blue one?
Yeah, the blue one. 8x squared. You got that from 4x times 2x.
Is this when you were in the bathroom?
Yes.
Okay.
Yeah, but I can't.
This one, alright, so you start with the first term in the first parenthesis.
No, I understand how like you're distributing.
Yes.
It
Uh-huh.
sounds like confused. Where
So
you
yes,
got
this one came from 4x times 2x.
So we're plugging in the imaginary line.
Yeah. Other questions?